Ashok Natarajan himself had shared an article sometime where he mentioned that the total supply that is happening is about 110 crores, but the actual receivables is only 60. So more than actually half of almost that is actually getting wasted in leakages and so-called theft. And that is by official admission. The actual numbers could be even more than that. So that is one of the like sort of key things that we refer to when we try to understand how do we actually make it work. So just to give an introduction about ourselves, the company that I run is called Fallness Integrity, and we are into robotics and digitalization of assets for water and sanitation. It primarily comes from our thought process that one, pipelines and these sewer networks, septic tanks that we call them, are everywhere. Like every person who is there in the city is associated with that in some way or other. And so far, we have been managing it in only manual manner, like whether it is cleaning, inspection, and so on. It's just done manually without any leverage of technology. If you look at the developed country markets, they have very established protocols on how these inspections of cleaning need to be done, but we have not adopted that so far. That is one. Two, we are still very sort of procurement heavy country in terms of these assets rather than maintenance. So in the sense that if you have pipeline networks built in the city, instead of, and when you start having problems, leakages, and the NRW increases, instead of actually identifying with a data-driven manner that which pipelines need to be replaced versus retained, you just like sort of start a contract of replacing the whole network in itself. So these are the things that we really want to work on. So I was was very fortunate to be a part of the post-budget webinar that happened yesterday, where Ministry of Jal Shakti was talking about how state is reducing non-revenue water, and they have this campaign called Har Ghar Nal Se Jal, which essentially means that how we can reach tap water in every sort of a house. And one key thing that came out was the laying out of the pipeline that will be critical, and how do we manage these pipeline networks. So a majority of my conversation today will be focused on the pipeline, and I'll very briefly touch upon the other work that we're doing. So in this the Prime Minister, Honorable Prime Minister himself mentioned that checking the integrity of these pipelines and their regular condition assessment will be most critical for us to achieve this mission. And that's what I'm sort of going to focus about today. Like what are the technologies and products that we can use to help us achieve this? So this is the context, like I said. One, we have a lot of existing water networks, and as per the official data, we have to expand more than like 1.3 lakh kilometers of pipeline network over the next 5 years. The other thing is that now there is like increasingly smart city networks have started to look at data-driven measures to understand what pipelines need to be replaced versus retained, rather than giving a blanket order of replacing all the pipelines. And the other thing that is there is that people have been talking about, given the water supply, we are talking about 24/7 water supply, becoming a 24/7 water supply nation. The leaks and contamination points that we generally have, they need to be resolved very quickly and detected accurately in order for us to do that. Because otherwise, what is happening is generally supply water if there is a problem, people would take 2-3 days to resolve it. Until that time, there is no water in the supply. That is the generally challenge that we see in the, and I just wanted to share this context, and majority of you would be aware of this because this is a similar context of every city. So what we want to see is, how do we leverage technology to actually help us reduce non-revenue water, have very early detection of leaks, and do quick resolution? How do we reduce this whole manual effort in doing so? So to give an example, if let's say there is a contamination or a leak complaints that come from a neighborhood, current existing work that people do is a jugaad solution, where what they do is they will try to identify from which one house the contamination complaint is coming and where the contamination complaint is ending. And they will have this 100 to 200 meter area where they would dig at multiple pits to identify where the problem could be. However, this is a very inefficient way of doing it. The thing that we are thinking about is if you can actually send something inside and we actually have a visual on what the pipeline condition is, you will be able to pinpoint exactly where the problem is. In this way, you will be able to reduce your digging significantly, solve that leak in like a matter of couple of hours, and save a lot of road asset, because otherwise digging of a road is itself a very tedious task, and you have to get permission from the road transport and so on. So these are a couple of things that we want to do. And in the long term, what we want to see is how is it possible that if we have intelligent data about how our pipeline networks are and where faults have happened earlier, can we predict also, in the sense that where the load is increasing and we can have possible failures, so that we can have regular inspections there. So this is really the thought process with which we are thinking about the solution. Now, this is the product that we have developed. So product, the way what we do is, it's a pipeline inline inspection robot that can go inside any pipeline above 50 mm in diameter. And the idea is that we have a camera which is able to record the entire pipeline. It's actually just like having an eye inside the pipeline, so that you're able to see the challenges that are there. You can also see the things that are corrosion that has happened. You are able to estimate the percentage of scaling, and thereby you will be able to take a data-driven decision on whether this pipeline needs to be replaced or whether you need to retain the pipeline. So this is something that we are able to do. And in terms of actually coming to the data point that I was talking about, right? One of the things that we have seen is every kilometer of inspection that we are able to do, direct cost itself, we are able to save about 7 lakh rupees for the municipality because of the digging, labor, road construction, and all of that cost that is there for them. And the other thing is that typically, even if we are able to find about 5 to 6 leak points or contamination points, that leads to a saving of about 500-600,000 liters of water every day, because of pressurized pipeline that we have. And this is just, we have estimated based on the 8-hour supply of water that is there. So this is what we have seen so far based on our work of like the 10 to 15 kilometers of inspection that we have done across various cities. And we feel that this number will essentially even become better as we develop better technologies. Because right now, even our technology has some limitations in terms of how fast can we do the inspection, how long can we do the inspection, and so on. So as we better the technology, as we leverage better technologies to do this, the cost savings will become even higher, and the savings of water will also grow. So I want to just show a couple of case studies that we have done. So this was a case study where we did in Chennai and Coimbatore, where you can see the condition of the water pipeline that was there. And to give an instance of this, like in terms of data, the total pipeline diameter internally was about 160 mm or so on, but the thing remained after the sludge and scaling formation was less than 100, like probably about 80 mm or so. That was the condition there. A couple of things you can see where the gaskets are coming out, and because of that rubber and everything, the water is getting polluted. So these were the couple of things that we noticed there. In our Trichy inspection that we saw that in a water pipeline, actually, there was a presence of a sludge. So because there was cross contamination, in majority of the cities, we will have water pipelines and sewer lines running in parallel. Now, you do not really know where the contamination has happened and for what reason. So if you're able to see these broken pipe sections and even the sort of some silting or seepages, you will be able to identify where the problem could be coming from. This was one thing that we did. Then we did something in Bhubaneswar. Bhubaneswar was quite shocking for us because this was a very newly laid pipeline. Like the pipeline was just laid about 5 years back or so. But within that, we were able to see a lot of stones. And this was later confirmed in Coimbatore also. And it's something we are trying to identify as a reason, that what could be the reason that we have so many big stones present in the network. One thing that we got to understand from the chief engineer was that probably because they sometimes dig the pit and don't close it immediately, there could be things that unwanted material go inside the pipelines, and they never know what is the condition of the pipeline, so they never really predict it. So this was a challenge that we saw there. This was another seepage issue that we saw in a sewer line, where so the walls had started breaking down, and that sewer, the sewer had actually started going out of the pipeline in normal groundwater and contaminating it. That was another challenge that we saw there. A couple of other ones that we did in this was a tree root penetration that had happened, primarily blocking the complete sewer line flow that was happening. And this is quite common that we have seen in the sewer lines because of sewer content that is there. This is quite nutritious in nature for the trees. So they tend to essentially break the pipeline and get inside and restrict the flow, in which case, even though the pipelines were laid like 5 to 10 years earlier, they see a lot of constriction and like blockages in their flow. So we were talking about how we can solve those challenges as well. So yeah, this is a bit on the technology side where we are working on a bit of laser profiling and further analytics to identify even if the data matter, like what is the effective diameter that has reduced, percentage of the corrosion that has happened, and so on. So this is a work in progress that we are doing. Apart from that, what else? So this is about the water part that we are doing. I will briefly talk about the sanitation work that we are doing also, which is we are developing so far India's first robot for septic tank cleaning, where we are essentially developing a cutter and a suction mechanism through which we will be able to clean any septic tank, whether it is a household septic tank or whether it is an industrial septic tank. And we have developed the whole thing keeping in mind the Safai Karamcharis or the manual scavengers who operate it themselves. So we have made it so easy to operate that earlier, if they were doing it manually, now they can just operate the tractor and they're able to clean the septic tank without having any sort of thing to do with the sludge. That is something that we have done. The sort of product is already built. We are thinking about deploying it and giving it in the hands of Safai Karamcharis after a week's time. So that is something that is a work in progress. And we will be distributing about 10 of these robots over the next 3 months to various groups of Safai Karamcharis. So yeah, then a couple of things about our team and the work that we've done overall. But we're happy to take any questions because I've already crossed my 10 minutes.